So far, we have talked about vectors, and those are described quantities that have both magnitude and direction. And we talked about vectors and describing them by basically drawing an arrow. And I mentioned that a lot because that won't always be the case. Pretty soon we'll talk about algebraic vectors, but not yet. We talked about what it means for vectors to be equal, vector equality. We talked about the zero vector, the negative of a vector, and we also, although I didn't write it on the page here, we talked about scalar multiplication as well, which is an operation that you perform with a scalar and a vector. And now we're going to talk about vector addition. We're also going to talk about vector subtraction as well. So what does it mean when you want to add two vectors together? We know what it means to add numbers together. You combine them, 3 plus 5. I can imagine 3 apples plus 5 apples, it gives you a total of 8 apples. So vector addition is obviously going to be different than that. We're going to talk about adding vectors is kind of combining them. And what we could imagine is if we imagine vectors being forces. I found this little picture of two guys pulling on a cart, and each of them is pulling with a certain force. And that force can be represented by a vector because it has a magnitude, the strength that they're pulling at, and also a direction, the direction they're pulling. We could imagine the combined force acting on the rail car as being the sum of these two vectors. And that's what vector addition is. It combines two vectors, and you can think about it as forces. So the combined force would be, some vector kind of down the middle here. Okay? If this person is pulling harder, then that combined vector should be a little bit closer to them. And you've seen this before if you've taken a physics class. Now, it's a good picture, except the rail tracks kind of mess everything up because as these two people pull, the tracks themselves also apply a force to the rail car to stop it from leaving the tracks, but we can just imagine that isn't there. Now, this idea of what it means to add two vectors just kind of gives you a visual picture of what it means to add two vectors together. We are going to define very specifically what it means to add two vectors together. And there are actually two different ways to calculate the sum of two vectors. We sometimes, instead of the word sum, we actually use the word resultant. And that depends on how the vectors are oriented. The first way to add two vectors is called the triangle law. And here's the definition right here. To find the sum of two vectors A and B using the triangle law, draw the vectors head to tail. The sum A plus B, often called the resultant, is the vector formed from the tail of vector A to the head of vector B. So we're going to follow those instructions. A plus B is the vector formed from the tail of vector A to the head of vector B. Now, with the vectors drawn head to tail. Now, these vectors are not drawn head to tail right now. But keep in mind that vectors, they don't have position. They just have magnitude and direction. So you can redraw vectors wherever you want. So for example, I could take vector A and I could redraw it here. I can take vector B so that it is right here. Let me try to do that correctly. Right here. So long as I keep the magnitude and the direction the same. And I mean, this is just a sketch, so even if it's not exact, that doesn't matter. So now I've got vector A down here, vector B here. And clearly those two vectors are head to tail. Now the instructions here say the A plus B is the vector formed from the tail of vector A to the head of vector B. So that is this vector right here. And there is A plus B. Now you can clearly see why it's called the triangle law, because the vectors are just drawn in a triangle. Another way of thinking about this, especially if you think about, if you're familiar with physics questions at all, if you imagine A and B were like displacement vectors, so they represented, a distance and a direction, taking vector A followed by vector B is clearly the same thing as just taking this line right here, okay? Same with two forces. If you wanted to combine two forces, this force A followed by force B, that would be the same as A plus B right here if you combine them. You don't even really need to understand that, though. The rule is just what the rule is. This is how you add vectors together using the triangle law. Draw them head to tail, then start at the tail of the first vector, end at the head of the second vector. Now, that is not the only way to add two vectors together, but we'll look at the second way in just a second. Let's take a look at this little problem here. Can you think of using the triangle law of vector addition to simplify the following? So here we have AB plus BC. Remember from yesterday, these are called point-to-point vectors. So what we have here is we kind of have 3 points, A, B, and C. And there I've drawn points A, B, and C just in kind of a random order there. Now we're talking about adding vector AB plus BC. So here's vector AB, and there's vector BC. Well, according to the triangle law, these are drawn head to tail. So to add AB to BC, I really just start at the tail of the first vector and edit the head of the second one. So there's the vector right there, which is equal to vector AC. In there, vector AC. There, that looks a little bit better. Now, I'd like to point out that you don't actually need to draw the picture to realize this. We can see that because we have a B and a B here, that we realize that AB plus BC will always be AC. So anytime I have that, I could simplify this to AC. I don't need a picture. I realize this is a vector going from point A to point B, and this is a vector going from point B to point C. So when we add them together, that's the same as just going from A to C. So I said there were 2 ways to add 2 vectors together. The second method is called the parallelogram law. And in the parallelogram law, rather than drawing the vectors head to tail, we draw them tail to tail. Now, it's actually more common to have vectors tail to tail than head to tail, and I've drawn these two with their tail together. Remember, the angle between 2 vectors is the angle made when they're tail to tail, which is often called theta. I don't know why there's a vector sign above the theta. There shouldn't be. But in any case, we complete a parallelogram in the parallelogram law. So what that means is that we redraw this side, vector A, we redraw it up here. Okay, it looks like that's about the same length. And we redraw vector B right here. Okay, so that's just, I've redrawn vector B and I've redrawn vector A. The sum A plus B is the vector formed in the diagonal of the parallelogram, starting at the tail. So then A plus B is just this vector right here. Now, you can see why this works. It really isn't any different than the triangle law. I mean, technically, if I was using the triangle law, all I would do is move vector B over here, and the vectors are head to tail. It's just called the parallelogram law because of the way that we draw the picture. And we're going to find the parallelogram law is a lot more useful, and it's more common. So we have 2 ways to add vectors, whether they're tail to tail or head to tail, the triangle law and the parallelogram law. Let's look at an example where we have descriptions of 2 vectors and we're going to add them together. Okay, so the problem that we're given here is that we want to find vector A plus vector B. We're given the magnitude of A is 10 and the magnitude of B is 4, and the angle between the 2 vectors is 60 degrees. So this sentence right here means this is the picture we have. Okay, I've drawn the vectors tail to tail, and the angle between 2 vectors is the angle formed when they are tail to tail, not when they're head to tail. So that's a reasonable interpretation of what the picture looks like. Since they're tail to tail, I've chosen to use the parallelogram law. So you see I've taken this picture here, I've redrawn it here, I've completed the parallelogram with vector A, which is 10, vector B, which is 4, I've drawn the diagonal, which is now the sum. So how do I proceed? Well, what I'm going to do is I'm going to look at the triangle that's in the bottom here. So I'll kind of highlight it here for you. There it is right there. Okay, and I'm going to solve for the magnitude of A plus B. Okay, and I can do that because although this angle here is 60 degrees, okay, I have this side and this side, I can figure out what this angle here is. It's actually going to be 120 degrees. Okay, and the reason why that works is, well, any 2 angles in a parallelogram that aren't opposite will always add to 180. And that's because these 2 sides are parallel, okay? And the interior angle theorem tells us that these 2 angles have to add to 180. If you remember learning about like the C pattern in grade 9, remember the Z, F, and C pattern? The C pattern tells you that these 2 interior angles add to 180. So then I have side, angle, side. I'm looking for the opposite side, and here it is right here. It's the cosine law, okay? C squared equals A squared plus B squared minus 2AB cos C. So there it is, 10 squared plus 4 squared minus 2 times 10 times 4 times the cos of 120, and I go from there. Now notice that the cosine of 120 degrees is actually negative 1/2, and that's because we know the cosine of 60 degrees is equal to 1/2. And so 120 would be this angle over here, where that side becomes negative 1 and 2. So the cosine of 120 degrees is exactly negative 1/2. So in this example, it happens to be that you can use an exact ratio for your trig there. That gives us a plus b squared is 156, pardon me. So the magnitude of a plus b is the square root of 156, which is also about 12.5. So the goal was to find this vector a plus b. And what we found so far is we found its magnitude. But technically, it's a vector, so it has both magnitude and direction. So we need to know the direction of a plus b. Well, the only thing we're given is the angle between vectors a and b. There's no other reference. So what we're going to do next to find the angle of a plus b is we're just going to find the angle that a plus b makes with one of the other two vectors. Now, if you think about it, vector a has a stronger magnitude than vector b. So it would make sense that vector a plus b is going to be closer to vector a than it is to vector b. If you think about vector a and b as being forces, if two people pull on something at the same time, the person who pulls with a stronger force, in this case 10, is going to have the object like pulled more toward them, if that makes sense. Like if I'm stronger than you, okay, and we both pull on something, even if we're pulling in the same direction, whatever we're pulling on is going to be drawn more to me, okay, because I'm so much stronger than you. So let's look at finding that angle. So we're going to find this angle right here, and I've actually called that alpha, okay? Theta is generally reserved for this angle here. And so you can see I've just redrawn the picture here. This same triangle is redrawn down here. We have 10, 4, we have 120, we have the square root of 156. We want to find this angle here. So we can actually use the cosine law or the sine law because we have all three sides, but we also have this angle here. I've chosen to use the sine law because I find it just a little bit quicker. So sine alpha divided by 4 is equal to sine 120 over root 156. Multiply both sides by 4, do your inverse sine, and you get about 16 degrees. And so now we're able to describe vector a plus b in its entirety. A plus b is a vector such that its magnitude is the square root of 156, and it makes an angle of 16 degrees with angle A. If you wanted to, you could obviously figure out the angle it makes with vector b as well. All you would have to do is, 60 minus 16. Okay, so 44 degrees with vector b. I always like to ask students, can you think about how we might subtract two vectors together? So we know how to add two vectors. How about subtraction? We don't usually get an answer to this question because we don't always think about subtraction as really just being addition, but it kind of is. If we want to know what a minus b is, we could realize that that's just adding the negative of b. So a minus b is really just a plus negative b. We know what vector addition is, okay? And we know what negative b is. It's the opposite vector of b, okay? It's a vector of the same magnitude but opposite in direction. Let's just take a look at what that looks like in a picture. Now, I'd also like to point out, too, that a minus b is a plus negative b. We could flip the order of these, though, and say it's negative b plus a. So if we want to know what a minus b is, we could take our picture of a and b, and we reverse the direction of b to make negative b. And now we're adding negative b plus a. We'll notice that the vectors here are head to tail, and so this red vector here is equal to negative b plus a, or a minus b. That's just the triangle law there that I'm using. So once I've got that, okay, and I know, of course, that this is 60. I know that this is 10. I'm using the example from before, by the way. And I know that this side is 4. Not really drawn to scale, but there it is. So again, I can use the cosine law. Okay, I've got side, angle, side, but this time with 60 degrees as the angle in between them. Oh, look at that, I had drawn it there already. So the magnitude of a minus b squared is 10 squared plus 4 squared minus 2 times 10 times 4 times the cosine of 60 degrees. Figure that out, and I get root 76, or about 8.7. Okay, so to subtract two vectors, just to summarize, you take the negative of the vector you're subtracting, and you just add the vectors together. So if I want to do a minus b, I really just end up doing this right here. Negative b plus a, and when I flip b, if the vectors were tail to tail, when I flip b the other way, now they're head to tail, and now I can use the triangle law. In this one, I've chosen not to worry about the direction that a minus b makes, and that's a little bit more confusing. So a minus b goes in this direction. So if you were to compare it to a and b, you would put its tail right here, and it would be going this direction here. Okay, we'll worry about that a little bit later on. Let's just review what we've talked about as far as adding and subtracting vectors together. So I've drawn a parallelogram here with vectors a and b. So here's vector a, here's vector b, and they're tail to tail. I've also completed the parallelogram by redrawing vector A and redrawing vector B. We learned, according to the parallelogram rule, that if you want to know what A plus B is, that's equal to the diagonal of the parallelogram. So there is A plus B right there. Now, how about A minus B? So A minus B, we said, was really the same thing as taking negative B and adding A. Okay, or taking A and adding negative B, but then switching it the other way around makes a little bit more sense. So if this is B this way, then negative B goes this way. So there's negative B in blue there, going the opposite direction. Negative B plus A, so just like the other example, now they're head to tail, so we use the triangle law, and we find that A minus B is just the other diagonal in the parallelogram. So there's A minus B. We've got the angle theta, right, which is this angle right in here. So the angle over here is 180, take away theta. Okay. Now, to figure out the length of A plus B, or the magnitude of A plus B, so just look at the right, just looking at the right now. Okay. So to figure out the magnitude of A plus B, we use the cosine law. A squared plus B squared minus 2AB times the cosine of 180 minus theta. So what I'm doing there is I'm basically using, sorry, that's 180 minus theta. I'm using this bottom triangle, okay, where I have side, angle, side. This is vector B again over here. And using that to figure out how long this diagonal is. Now, there's a little trick. Oh, and then if I look over here, A minus B squared is A squared plus B squared, and I use this angle because to figure out A minus B, which is this one right here, I'm using this triangle on the left. So here, here, and here. I've got B, I've got A, and now the angle in between them. But look at, there's something I can do with cosine of 180 minus theta. The cosine of 180 minus theta is actually the negative of cos theta. And that's because if you think about the Cast rule, if you have theta right here, then the cosine of theta is x over r. And if you have 180 minus theta, that is the same picture over here, where r is the same, but x is now negative. So in general, the cosine of, think of two angles that add to 180, 30 and 150. The cosine of 30 is the negative of the cos of 150. The cos of 20 is the negative of cos 160, and so on. In fact, we used that idea right here as well, where I said, oh, hey, cos 120 is just negative cos 60. So because of that, we can replace cos 180 with negative cos, and then look at the two negatives. A negative times a negative gives you a positive. So although you don't actually ever need to use it, this formula will also give you the magnitude of two vectors if you know the angle between them. Remember, the cosine law has a minus as part of its equation, okay? But if we want to replace, because we use the supplementary angle, if we want to replace it, we can actually replace the negative with a positive. It's kind of like you're trading off two negatives. I know that this is the negative of that, and so these two negatives become positive. And then I didn't change anything over here. This is just the same. So I don't know. I don't want to confuse you by giving you another way to do something, but really you could just always do this calculation if you wanted to. So basically instead, if I look back here, instead of figuring out 120, I could have just said, oh, use cos 60 and then change this negative to a positive because this will be the negative of the angle I want. After that, the direction of a resultant can always be found using the sine law. Okay, as far as the work goes, you'll find that some of the solutions to these problems, there's full solutions in OneNote for you to look at. Question 1C asks you to find a vector equal to u plus v. There's really no way to do that in the picture, so don't worry about that one. You can just skip it. Number 20 is probably the first challenging question in this course. One thing you need to know is they refer to vectors I, j, and k, and they got these little hat symbols on them. That's a symbol for a unit vector. So basically means I, j, and k are just vectors, and their magnitude is equal to 1. So you need to know that. In OneNote, there's a partial solution for question number 20. You may need to look at that just to get started on this question because most students do find it rather difficult. Keep in mind, this material is also in your textbook. So if some of this was confusing, don't be shy about reading the examples in your textbook and seeing the way that they provide some explanation. Now, section 4.2, I believe it is in the textbook, they go further than we went in this lesson. We'll get to the other material, but we didn't cover it all yet. So reach out if you have any questions. I know that vectors is really different, and it can start to give people a hard time, so don't be afraid to ask for help.